Welcome to the lesson for 8.2. Today we're going to talk about arithmetic sequences and partial sums. Well, let's talk about what exactly is an arithmetic sequence. And we already ran into one of those on the first day or day 2 in lesson 8.1. So we're going to talk about that in just a minute. Well, if a sequence or series is arithmetic, this is what is true. There is a common difference between consecutive terms. Okay, so what we have to do is we have to identify this common difference, and that's denoted with the variable d. So when we're looking for the common difference, the order matters. And so what you're seeing down here is, for explicit terms. So to find the common difference, we always do the final minus the initial. And think back to slope. We did that y2 minus y1. It's the same idea. So again, if you're looking at two terms right next to each other, you do a4 minus a3 and so on, the final minus the initial. Now, all sequences and series that are arithmetic are linear. Okay, and so that means that the explicit formulas for these are going to be y equals mx plus b. Now we're going to use different variables, but that's what the explicit formula is always going to turn out into. So just kind of keep that in the back of your mind. The nth term for arithmetic sequence can be derived from the pattern below. So I want you to go back and think for a moment. If you go back to example 4 from lesson 8.1, we generated the terms of the pattern, and we generated 25, 20, 15, 10, 5, and we could have gone on and on and on. So if you, again, think about the term position, so the first term here was 25, and then the second term was 20, and the third term was 15, and then so on. So if you notice, we've got that common difference here of -5. So again, if I were actually trying to do the math here, I would do the common difference, so take two terms. So let's just do like 15 and 10. So we would do the final, which would be 10 minus 15, and that would give us, the -5. Well, in my formula, y equals mx plus b, the common difference is the slope. All right. And then if you recall, what is the y-intercept? Well, that's when the graph crosses the y-axis. So if we stepped backwards one and did like the 0 term, if you will, that would be 30, and so that would give you then the b for your pattern. So then the explicit formula here would be a sub n equals -5n plus 30. And again, we're gonna continue to work on this. So also sometimes we look at the graphs for these, and so the graphs, if you think about these as ordered pairs, okay, the ordered pairs go in n and then a sub n. So the term number, the term position, and then the term's value. So if we just look, at an example here like 20. So we would say that position number 2, the term's value is 20. And then again, obviously we could graph out the points if needed. And then again, the graphs for a linear equation are always going to be linear functions. And so you can kind of, put all those pieces together. Now, in general, how do we find the nth term for the arithmetic sequence? We can use this formula. A sub n equals a sub 1 plus quantity n minus 1 times d. But then you always need to simplify this. Okay, and again, d is said to be the common difference between the consecutive terms, and then a sub 1 is said to be the first term of the sequence. Now, think about your other, linear patterns that we have, or linear equations. We've got point slope form, so y minus y1 equals m times x minus x1. So it actually looks more similar to point slope form if we were to solve that for y. And then again, we've got y equals mx plus b. Another version of the explicit formula in, terms of sequence symbols, I guess, would be a sub n is equal to a sub 0 plus d times n. Okay, so this is the one that I tend to, go with whenever I can because I think it's the easiest one to use, or I use, this version here. Let's come down to example 1 and find a formula for a sub n for the arithmetic sequences. So again, they're asking us for the explicit formulas. Okay, well, notice, for example, A here, they give us a sub 1 and d, so all we have to do is just put that into our formula. So we have a sub n is equal to 5 plus negative 3/4 times n minus 1, and then simplify. So negative 3/4 n, and then plus 5 3/4. And that would be fine. If you wanted to make that into a improper, that would be fine too. So we'd have 23/4, and voila, pretty straightforward. Okay, looking at example B, notice that they're giving us the sequence written out. So here we need to first find the d value. So take two subsequent terms, whatever ones you want, and then find the common difference. So we do 1/4 minus the negative 1/2. And that's going to give us 3/4 for the common difference. Now here, I'm going to use my formula of a sub n equals a sub 0 plus d times n, because since I have the sequence written out, I can just work backwards one step to get the 0 term. And so then that would be a matter then of minusing 3/4. So I'd have negative 2 3/4 for my value on the 0 term. And then we can just put that all together. So we'd have 3/4 n minus 11/4. And again, if you wanted to do negative 2 3/4, that would be fine too. Okay, looking at example C, notice this time they're giving us two terms. And so that's fine. So as an ordered pair, we'd have term number 5 is 190, and then term number 10 is 115. Okay, well, how are we going to do this one? Well, you need the slope in between the 2 points. So the slope here is going to be y2 minus y1 final minus initial, and then same thing for the denominator, x2 minus x1. And so notice that we get negative 75/5, and that reduces to negative 15. Okay, next. So this time I'm going to use a sub n is equal to a sub 1 plus n minus 1 times d, which is negative 15. Now, notice that you have two terms to work with. So I'm going to substitute the term value and the term number so that I can solve for a sub 1. So I'm going to use 5 and 190, but it doesn't matter which point you want to use. So we have 190 is equal to a sub 1 minus 15, 5 minus 1. And then solve for a sub 1. So 15 times 4 is going to be 60. And again, don't lose your negative. So then notice that we get a sub 1 to be 250. And then I can just go ahead and put all of my pieces together for my formula. So a sub n is equal to 250 minus 15n. Okay, now for my last step, I'm just going to put all the pieces together. So I have a sub n is equal to a sub 1 plus d times n minus 1. For my last step here, I just need to put in all of the pieces and then simplify. So I have a sub 1 was 250, my d was negative 15, And notice then that my explicit formula then is going to be 265 minus 15n, and that is the final answer here. Looking at example 2, we're asked to write the first 5 terms of the arithmetic sequence, and notice that they're providing 2 of the terms to us. Okay, well, we're going to work basically with just like what we did on the last one. The first thing we need to do is find the common difference. Again, notice that if you were to revise the given information into ordered pairs, we would have 5 and 16 and 14 and 38.5, and then we can go ahead and do the slope. 38.5 minus 16 divided by 14 minus 5. In doing so, you're going to get 5 halves once you reduce on that. Okay, next we want to go ahead and find the first term. So I'm going to use my formula a sub n is equal to a sub 1 plus d times n minus 1. Use either of the 2 points. I'm going to use the first one. And now I'm going to solve that for my first term here, a sub 1. So then notice that we would get 4, and then we would get 10 from that. So then I get my first term to be 6. And now I can proceed with my explicit formula. So my explicit formula, a sub n is equal to a sub 1, which is 6, plus d, which I just found to be 5 halves, times quantity n minus 1. So my explicit formula here is 5 halves n minus 5 halves. And so we would get a sub n is equal to 7 halves plus 5 halves n. Okay, and the whole point of this is to give us the explicit formula so that we can go ahead then and generate the 5 terms of the sequence. All right, so now that I've got the pattern, now I'm going to go ahead and work it. So my first term here is going to be 7 halves plus 5 halves times 1. That's going to give us 12 over 2, which is 6. And again, we already found that here, in this prior step, but I just want to show you, that it all works out. Okay, the next one is the second term. So 7 halves plus 5 halves times 2. And so this time we're going to get 17 halves. The third term, 7 halves plus 5 halves times 3. And so this time we're going to get 22 2's, and that reduces to 11. Okay, a sub 4, got 7 halves plus 5 halves times 4. That's going to be 27 2's. And then a sub 5, they gave that to us, so I'm not even going to waste my time with that, and we get 16. Writing that out as a nice list, we would have 6, 17 halves, 11, 27 halves, and 16. Example 3 says to write the first 5 terms of the arithmetic sequence, find the common difference, and then write the nth term of the sequence as a function of a sub n. All right, so we've got 3 things that we have to do. So first we have to, generate the first 5 terms, and then we need to formally state the common difference, and then write out the formula for the explicit function, which is a sub n is a sub 1 plus d times n minus 1. So that's what they're telling you there. Okay, notice that we're given a recursion here, and so each term here, the next term, is going to be found by taking the current term and then subtracting 2.5. All right, well, let's just go ahead and start generating the pattern here for step number 1. All right, well, my first one was 1.5. Okay, well, if I take away 2.5 from that, because that's what my formula says to do, then notice that you get negative 3.5. And then if I take away 2.5 from that, I get negative 6. And then if I take away 2.5 from that, I get negative 8.5. And then if I take away 2.5 from that, I get negative 11. All right, so again, in my mind, you know, I'm just doing minus 2.5, minus 2.5, minus 2.5 instead of writing it out so formally. Okay, so I've got all of my numbers then. Let's just write those out nicely. So I have 1.5, negative 3.5, negative 6, negative 8.5, and then negative 11. Now you should be able to see what the common difference is. Each time we did a step, we subtracted 2.5. So the common difference here is negative 2.5. Now writing out my explicit formula, well, I'm actually going to work backwards one, and I'm going to plus 2.5 to that. And notice then that you would get 4. And so that's like the 0 term. Well, then that means that my formula here would be a sub n is equal to negative 2.5d, or negative 2.5n, sorry, and then plus 4. And again, the version that I'm using for this is kind of the simplified version. And again, that's because I had, you know, the first 5 terms. If you have the first 5 terms, then I think it's just as easy to find the 0 term. We can also use our calculator to, you know, generate however many terms we want and then write it out for us. So let's just run through and make sure that we understand how to do that. So going to your graphing calculator. Okay, the directions say to use the table feature, so that implies that we need to go to y equals to input, you know, our formula and then go to the table from there. So the formula here is negative 12.4n plus 9. Okay, and then just hopping over to my table. And then we've got term number 1 all the way through term number 10. And so this is all that they're asking you to do here, is to recognize that. Now remember, we can also generate the sequence using our other command here. So if we go to list and then ops, if you remember the sequence command. So we could, you know, go through and do all that if we wanted. And, you know, that's just another option, but the directions say to use the table, so that's why we're using the table here. So negative 12.4n and then plus 9. You don't really need the parentheses there. So we want to start at 1, end at 10, step by 1, you know, and there you go. It's the same thing. Notice that there's a right-handed arrow here, so you'd have to use your arrows to see the full list. And then if you want the fraction version, you can always do math and then fraction, and then it will give you those values as fractions. Okay, make sure and jot those down on your paper, and then we will continue on. The next piece here is the formula for finding the sum for finite sequences. So instead of just blindly adding up all of the terms, there's actually a formula for a finite arithmetic sequence with n terms. And so the formula is S sub n is equal to n over 2 plus quantity a sub 1 plus a sub n. Okay, making sure that you understand the parts here. So n is the number of terms. A sub 1 is the first term. In the series, and then a sub n is the last term in the series. So you don't necessarily have to start with the first term. So, you know, be mindful with that. We can start at term number 7. Now here you kind of have to be careful about what you use for the n value, and here's why. If we start, so if we're given a sum and we start with 1 and then go to 7 for, you know, whatever the formula is, like 2i, the number of terms to find n you do the max minus the min and then plus 1. Now the max minus the min plus 1 is always going to be the upper limit of summation only when you start with 1. okay? So it's better just to use this generalized form for all of them instead. Okay, so here's the next example. If I were to start at the 0 term and then go to 7, you would not have 7 terms here. You'd actually have 8. So you've got 7 minus 0 plus 1, and that gives you 8. So that's why it's always better just to use this formula instead of only looking at the upper limit, because the upper limit is only going to be that value if you begin with 1. And obviously we're not always going to begin with 1. So it's just safer to do the max minus the min plus 1 each time. Let's go ahead and find the nth partial sum of the arithmetic sequence. Alrighty, so notice that we have a sub 1 is 15, a sub 100 is 307, and then they're telling us that n is 100. So we would have s sub n is equal to 100 over 2 times 15 plus 307. Okay, they won't always be this straightforward. And actually s sub n, we could go ahead and we could replace that with 100 because they tell us that we're doing 100. Okay, so then we get 50, and then the sum of 15 and 307, which is 322, and obviously you're going to need your calculator. And we get 16,100 here. Okay, looking at the next, we've got a sequence here. Now this one's trickier. They tell us that we're going to the 12th term, but clearly they don't give it to us. They give us the first term, the second, the third, the fourth, and so on. And so in order to do my pattern, I have to find the 12th term. Well, that's why this one is harder. Okay, so I need a sub 12 here because you can't do the sum formula without it. Alrighty, well, this one you can, figure out the explicit formula fairly easily. So a sub n is going to equal, okay, what is the common difference here? You should be able to do that in your head, that the common difference is negative 1/2. And then if you worked backwards one term to the 0 term, you would get 4.7 for the 0 term. So the explicit formula here is 4.7 minus 0.5n. Now to find the 12th term, we're going to evaluate the formula at 12. It's going to give us 6. And so then the 12th term here is negative 1.3. Okay, now I have everything that I need for my formula. So s sub 12 is going to equal 12 over 2 times 4.2 minus 1.3. And then just doing the math there on my calculator, I get 17.4. Looking at example C and D down here. So here's a good example of having to do a little bit more work here because they're just giving us the sigma notation or summation notation. So I'm going to have to do all of my steps here. Well, number one, I need to figure out n. So notice again, I'm not starting at 0. So that means you don't have 18 terms. You've got to figure out the n. So we do 18 minus 0 plus 1. And we actually have 19 terms here. Now you need the first term in your pattern, which is going to be the 0th term. Well, that's negative 4. And then you need the last term, which is the 18th one. And so when you do your math for that, we get 50. Okay, now we put it all together. So s sub 19 is equal to 19 over 2 times negative 4 plus 50. Do your math on that, and we get 437. So again, that's why the notation here is a little bit confusing with the box, because this first term here just implies the first term in the series, not like literally the first term. So, when you're starting at something besides 1, be mindful that that's the first term in your series. And then the same, is going to go for this next example for D. I'm starting with term number 51. That's the first term in my series. So Okay, again, basically it's the same thing. So we're going to do the number of terms. So max minus min plus 1. And so notice that we get 50. And then I need the first and last term. So a sub 51 is my first term. And then doing the math there gives you 359. And then my last term here being 100. And we get 702. Okay, and then just putting that all together. So S sub 50 here is going to be 50 over 2 times quantity 359 plus 702. And so we get the sum of these 50 terms to be 26,525. Again, our graphing calculator can do this for us. I should actually have n equals 0 there for the lower limit. So if you flip over to your calculator, we can just use the summation command. So again, alpha window, and then the summation command is number 2 here. And then it's just a matter of just typing in, all of the pieces. So we have n equals 0, and then our upper limit was 100. And then you just type in your formula. So we've got 8n plus 3 quantity divided by 16. And then voila. If we wanted the fraction, we could just do math fraction. And there we go. Okay, I do have the old screenshot still for the old operating system. Again, this is like really, arduous to put in. This is what it would look like once you've, done the commands for that. So if you're working on the old system, please make sure that you are able to get that typed in. But it seems each year we've got fewer and fewer students with the old one. So probably in the not too distant future, I can delete those. Let's look at the very last one here, which is an application. Determine the seating capacity of an auditorium with 36 rows. There are 15 seats in row 1, 18 in row 2, and so on. Well, let's just try to generate what's happening. So the row number here, and then how many seats, the number of seats. Okay, row number 1, we've got 15. Row number 2, we have 18. Row number 3, we've got 21, and so on and so forth until we get to 36. All right, so again, determine the seating capacity would mean to find the sum of all of the rows, the sum of how many seats, are in each row. Well, we're going to need to go ahead and figure out then our explicit formula so that we can generate how many seats are in row 36. So I need a sub n. Well, we can do that very easily by doing a sub 0 plus d times n. Notice that your common difference here is going to be 3. And then the 0 term would be 12. So 12 plus 3n is going to be the rule for this. Therefore, a sub 36. And we get 120. Okay, and then we can go ahead and put all of the pieces together then. So then my sum here, so S sub 36 is going to be 36 over 2 times the first term was 15. The last one was 120. And then doing the math there, we get 2,430 seats. So that auditorium can fit that many people in it. Alrighty, hopefully you found this lesson to be, not too bad. The recursion part maybe is a little bit tricky, but working with arithmetic sequences and series is very straightforward because the equations are linear functions. And that's, something that's we understand really well. That was the first kind of equation that we really started working with, those kind of functions, all the way back in middle school. Please make sure to get your assignment turned in to Canvas, and then of course make sure to let me know if you have any questions.